everyone, including Waterdown and all our camps watching the live stream this morning. As you may know, we have Dr. David Pearson with us today, and he's a professor of earth sciences at Laurentian University. So he's calling in today from Sudbury. In a little bit, he's going to tell us a bit more about what he does as an earth scientist, and I think he's going to even show us some fossils, so that will be very cool. So today, the campers are using common kitchen items and ingredients and turning them into science experiments. And one of the projects today is building a tabletop volcano. So I'm sure they have all sorts of questions about volcanoes and rocks and things. So before we get to the questions, I'll go back to you, Dr. Pearson. Could you tell us a bit more about what you do as an earth scientist?
Well, I am now very interested in the way that the climate is changing. So earth scientists sometimes don't look at rocks, they look at what's going on the surface of the earth, not just inside the earth. But when I was as young as the campers that I see there, I was very interested in fossils. And the reason I was interested in fossils is that I lived up in northern England. I didn't live in Canada, I lived in northern England, and I lived near the coast. And I used to pedal my bicycle down to the coast, to the edge of the sea, where the sea was wearing away the cliffs of rock, and there were steep cliffs. And in the rocks of the cliffs, there were fossils, fossils of shells and fossils of corals and things like that. And I picked them up and collected them. So one of the things I learned as a kid was to get out on my bike and to go to interesting places. And I became interested in fossils that way. But I also messed around with tabletop volcanoes as well. So I did some of the sorts of things that you're doing today.
Great, thank you. So let's go to maybe our first question in Waterdown. Is there a question for Dr. Pearson in Waterdown this morning?
Yes, there is.
Great.
Why when you put food dye in oil, it doesn't change color?
What do you put in the oil? I didn't quite hear clearly what it was you were putting in the oil.
Food coloring.
Oh, food coloring. Well, most food coloring is made so that it dissolves in water and makes jellies red or yellow or pink or blue. And lots of things that dissolve in water don't dissolve in oil because it's very, very different. And one of the experiments that you might try, if you have some oil, and maybe it's the kind of oil that you have at home for making locks work more easily, and you put some of that oil in a cup, and you put some water in the cup, and then you put the food coloring in, what you'll see is the food coloring will dissolve in the water, and it won't dissolve in the oil, just like you said, and that's because oil and water are so different, very, very different from each other. And that's a very interesting thing to do. And you can keep pouring different colors in. When I was a kid, I used to go to my grandma's every weekend, and part of what we did was to make jelly. And I know that one of the things I loved to do was to mix all the jelly colors together. And what you get is you get a really yucky kind of brown-gray color. So try mixing oil and water and then putting the food coloring in, and watch the food coloring dissolve in the water.
Great. Thank you for that first question, Waterdown. I'm going to go to our first question from Twitter. And just a moment here, let me find it again. So Dundas, our camp in Dundas, Ontario, they want to know, why do volcanoes exist?
Well, volcanoes exist because inside the Earth, it's very hot. About 100 kilometers down beneath your feet, the Earth is like a hot slushy. It's not quite all liquid, but it's, if you can imagine a hot slushy, that's what it's like. And that hot slushy is trying to find its way to the surface. It's trying to ooze up through cracks in the rock and reach the surface. It's a little bit like blood inside your skin. You know, if you cut your skin, the blood comes out. Well, that's a little bit like what it's inside the earth, except instead of blood, it's hot slushy. It's hot rock that's almost melted, and it's trying to find its way to the surface. And wherever it finds a crack, it will burst through. And I'm not sure whether I can show you a picture of something like that. How do I share my screen, Anne? Can you tell me very quickly, or should we not try that?
Yeah. So the window where you typed in the number for today in the contact
Yes.
list, at the bottom of
Yes.
that window there's an orange bar,
Yes.
and on the
It
far
says
right
history?
it says share.
I
But
see.
at the bottom of that,
Oh, I see share. Yes. Yes,
yeah.
yes.
So if you click that, now you have to have your window that you want to share already open, and then there will be a list of everything you have open, and you can share by selecting it.
Does that show you anything?
We can't see that.
You can't
Still
see
see
that.
you.
Okay. You can still see me. Okay. Well, we'll go back to B, and I'll have to talk about it because one of the very, very interesting kinds of volcanoes are the kinds that in which diamonds are made. Many of you, when you go home, will be able to ask your mom or your grandma or somebody who wears a ring to ask them if you can look at their diamond. And diamonds come up in volcanoes that erupt from, do you know the word erupt? They sort of burst upward from about 150 kilometers. And that's the distance from Toronto to Barrie. Or it's almost the distance from Barrie to Parry Sound, for those of you who know the roads around where you live. It's a long, 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 long way. And they have to burst up very quickly in maybe an hour or two. And those volcanoes burst right through to the surface of the earth. And when they come up, they bring diamonds with them from way down below at about 150 and 200 kilometers. So they come from a long way down. So next time you see a diamond, you're looking at an exciting gem that came up with a volcano. Now, let me ask you a question. Can I ask them a question, Anne?
Absolutely.
Can I ask them? What are you going to make your volcano out of? What are you going to use? What will you use to make your volcano?
Baking soda and vinegar.
Yeah, can you tell him?
Baking soda and vinegar.
Ah, yes, baking soda and vinegar. That works very well. That works very well. And part of what you might do is you might, yeah. Well, I'll leave your I'll leave you all to figure out how to do that, because I don't want to talk about a way to do that is not part of your plans. But yeah, that's a very good way to make a volcano. A very good way. You'll have lots of fun. You'll have lots of fun with that. Now, and it won't be hot. You know, most volcanoes are hot, of course. You know, and molten rock comes running out, and you won't quite get that, but you certainly will get an idea of how explosive a volcano could be. Have fun with that. Have fun. I've done that. My kids have done that. We've had lots of fun with it. Anne, you had another question?
Yeah. Well, keeping with our discussion of volcanoes, both our camps in Paris and St. Thomas want to know how and why do volcanoes explode? You sort of talked about why they exist, but what would make them erupt?
Explode. Well, that's a good question, and it's because dissolved in rock, and this is hard to imagine, but when rock is molten and you can see it erupting on the surface in lava flows, there are gases dissolved in lava. Um, and maybe one of the kinds of gases you can imagine is water. You know, when water is boiled in a pot, it turns into gas and it leaves the pot, and you see it as steam. Well, in rock, there's a little bit of water dissolved as well. And when the rock melts and starts to ooze its way to the surface, like I mentioned, the little bubbles of gas that are dissolved in the rock get bigger and bigger and bigger because the whole mess is closer to the surface and the pressure is less, so that the pushing down is less. So the bubbles get bigger and bigger and bigger, and as the rock gets closer and closer to the surface, those bubbles come together and they make a big bubble. And when that bubble reaches the surface, it bursts. And so it's the bursting of bubbles, the bursting of gas bubbles dissolved in the molten rock that makes a volcano explode. And those explosions can be very, very violent. And let me show you a rock here that I think you'll be able to see. This, do you see, how clearly can you see this rock? Can you see it's made of, well then I'll try to get it in my camera. There's, how well can you see that? Can you see there are bits and pieces in this rock?
Yeah, a little bit.
Bits and pieces of different colors. And that's a rock that was made by an explosion. And let me show you how that explosion happened. It was not an explosion like a volcano. It was an explosion that happened like that. That rock was made by the impact of a meteorite. It built a crater. It made a crater near Sudbury, and all of those bits you saw were thrown up into the air by the explosion, and they fell back into the crater. But when you first see that rock, it looks very like a rock from a real volcano. But it was from a crater. So part of what you find when you're a scientist who looks at rocks is you always find surprises. You always find surprises, and you always have to look at a rock carefully and think about how that rock might have been made. And there are all sorts of different ways that rocks are made. So there's always a surprise. Every day brings a new surprise when you're looking at the Earth.
Yeah, speaking of surprises and rocks, our next question from Dundas, they submitted a picture. So let me just see if I can share it here. Something they found in their backyard.
Mm-hmm. Which just goes to show that you don't have to go on expeditions to find interesting rocks. Just look in your backyard.
Yeah, I hope that that's big enough that you can see what's in the picture. They want to know if you can tell them what it might be.
Does it look like a shell? Can I ask, are there Dundas people there and able to answer a question?
You can ask it, and it might take them just a minute to reply via Twitter. That's how we're communicating with them today.
The first thing it looks to me like is it looks like a fossil. It looks like fossil shell, and it looks to me like a kind of fossil that's actually called a brachiopod. If I'm right, and if you're in Dundas, you can tell me that I'm wrong, and it doesn't look like a shell at all, that it's different from that. It seems to me that it's a shell that's made of two parts. And I'm going to just go back from my camera a little bit so that I can show you this. Two shells that opened. Down, up, no, down, up. There we go. So two parts of a shell that opened like that. A bit like what you would probably call a clam, but I think actually it's a little bit different from a clam, and it's what we would call a brachiopod. So that's what I think it is, but I must say it's very small on my screen, and I might be totally wrong. So is anybody from Dundas there who can say that this looks to them a bit like a fossil?
We haven't heard
We
from
haven't
them
heard.
yet.
Well,
Might be a
that's
bit of a
okay.
delay. Yeah.
That's okay.
So,
That's what I
it just
think
came
that.
in. They say no, it's not a shell.
Ah, but is it a fossil shell? It doesn't look like a fossil shell. Well, then they can't make it any bigger, can they? It looks.
I can try. Does that help?
No. I I think maybe I need to. Can they hold it in their hand and turn it around? Is that possible?
Well, unfortunately, they're not joining us on
Oh,
video
I see.
today.
I
Yeah,
see.
makes it a bit hard.
Hey, well, if if they can make it a little bigger and send me a picture, I'll see what I can.
Okay.
I'll see what I
So,
can
so
do.
maybe later today, if we can't get the
Yes.
picture in time for the call, maybe later today I can forward you the picture, and you can reply through email.
Yes, I will. I will try to do that. I will try to do that.
Okay.
The very
Great.
best thing is always to have the rock in your hands. You know, and sometimes geologists will lick a rock that they're trying to identify. And the reason for that is that if you lick a rock, it makes the surface reflect a little bit. So if you turn it, the grains in the rock or whatever the rock is made of will shine at you a little bit. And you can sometimes identify a rock by licking it and then turning it in the light and looking at the patterns that you get. I wouldn't recommend that you lick all the rocks in your backyard, but sometimes that's an okay thing to do.
Yeah.
Sometimes.
So I'll go to maybe one last question. Is there another question we can go to in Water Down? Any questions about rocks or the earth? Maybe not.
Yeah, no, we've got
Well,
one.
What happens
well,
when there's like
what happens?
Repeat your question.
what happens when there's an earthquake?
What happens when there's an earthquake? An earthquake is a crack in the earth. And the reason that cracks happen in the earth is that hot slush that I mentioned to you earlier, that comes up in volcanoes, is also moving around just like soup. If you've looked at soup in a pot on a stove when it's getting hot, you'll see that it moves around. What we call that is we call it convecting. It's sort of moving around, and that hot slush inside the earth is moving around a little bit like that. And what it does is it pulls apart the rocky part of the earth, and it makes the rocky part of the earth crack and slide a little bit. So it's all of that internal, you might say, churning or internal moving around of the hot slush that cracks the rocky shell. Think of the earth like an orange, and think of the skin of the orange like the rock of the earth, and imagine that the soft part of the orange that you eat that's tasty, imagine that's hot and it's churning a little bit and it's sort of pulling apart the skin of the orange, or it's pulling apart and sliding apart the rocky shell of the earth. So that's why earthquakes happen. The earth is a very lively planet. It really is, because it's hot inside, and when you've got something hot inside and a shell on the outside, There's always stuff that's trying to get to the surface, and there's always churning that's going on inside the earth.
Great. So before we go, I know we're sort of coming to an end, but Dundas sent in another picture, and I think I can see a fossil in there. So, whoops. Let me know if it's any better for you. I think that sort of looks like a fossil to me, maybe.
It looks like a fossil to me. Let me show you a fossil that I have right here that looks to me a little bit like that. Can anybody see this? No, you can't. It's too small. Even if I get it close. No, that's no good. That's no good. But yes, I'm even more sure that the gray part there, the gray part is shell, fossil shell, and the light colored, the white part is what we would call limestone. And if Dundas can borrow some vinegar from Downsview? No. Anyway, if Dundas can find some vinegar,
their own vinegar.
they might have their own vinegar. If they can find some vinegar, put some vinegar on the white part of that piece of rock, and see if it fizzes. If it fizzes, it's limestone, and I would bet that the little gray patches in there are actually shells. And what you could do is you could put a bit of vinegar on the gray part and see if it fizzes, and in that case, that is a shell, and that's a fossil shell. I'm pretty sure that's a fossil.
Awesome.
And vinegar will help you be sure.
Great. So Dundas, if you don't
just put vinegar on French fries, you put vinegar on rocks too.
Yeah. So let us know if you do that, Dundas, and how it goes. I'd love to see how that test goes and what it turns out to be. So I think that's all the time we have with Dr. Pearson today. I'd like to thank him so much for taking the time to call into our camps and answering all our questions, including trying to deduce what that rock might be. That was very interesting to hear. So thank you very much.
Well, it was my pleasure. I'm glad to meet you all, and good luck with your volcano. Good luck with your volcano. And maybe you should add some food coloring to your volcano too, so that you get red colored lava. So put some food coloring in your baking soda.
That's a good idea. And thank you to all our camps for submitting all your great questions and that picture as well. That was very exciting. So thank you, everyone, and have a great day. We'll see you next week. Thanks again, Dr. Pearson.
You're very welcome. Bye from me. Bye-bye. Bye, everybody. Have a good day. Water down. Right. Water down. Bye.
Bye.